Okay, problem number 2. A child tries to flick a piece of popcorn off a table into a bowl on the floor. If the bowl is 50 centimeters away from the table and the table is 125 centimeters tall, what is the horizontal velocity with which the child must flick the popcorn? Okay, so once again, it's that projectile type problem. Let's write down what we know. We know the height of the table, right? The bowl is 50 centimeters away from the table, and the table is 125 centimeters tall. So let's start with that. Delta y is 125. It's going to fall, so we add a negative. Now, here's the problem. We are dealing with centimeters, not meters. We don't like centimeters, so we need to convert that. It's really easy, guys. You just divide by 100. So since there are 100 centimeters in a meter, we divide that number by 100 and we get our amount in meters. When you divide by 100, you're moving the decimal place 2 to the left. So rather than 125 centimeters, this will be 1.25 meters. Good. What else do we know? Well, we know the bowl is going to be 50 centimeters away. So our delta x, because we're dealing with that distance out, is 50 centimeters, which would be 0.5 meters. Once again, moving that decimal 2 to the left. Okay, other things we know, it's a projectile, so it's going to be affected by the force of gravity acting downward at negative 9.8 meters per second squared. And we also know that velocity initial in the y direction, that vertical, is going to be 0. Okay, they ask you in the final question, what is the horizontal velocity that it must be flicked? So they're wanting to know Vx. What is that value going to be? Okay, the only equation we have for Vx is right over here. It's talking about that constant velocity to the right, and you just have to take your distance it travels to the right and divide it by the time it takes to get there. So we want to use this equation, delta x divided by delta t. Well, we know what delta x is. It's 0.5. The trouble is we don't know what delta t is. So let's think back to the last problem really quick. In the previous problem, they first asked us for time, and then we used that time to solve for the distance. It's the same idea here. They're asking us for velocity, but we need the time in order to do that. So this is a two-step problem. The first thing you're going to have to do is solve for time. So just like the last problem, use that delta t equation, square root of twice your height divided by acceleration, plug in your delta y, plug in your acceleration, find out the time, and then use that time in this equation to solve for that velocity in the x direction.